Okay, so hello everyone. In this video, we will be solving the question number 3731, which is find missing elements. It is marked easy. The question is very easy to understand as well. Constraints are very small. So we will first understand the question, look at the constraint, understand few examples, and then form our approach. And finally, we'll implement it. Okay, so let's first understand the question, what the question wants to say, and then we'll move to the constraints and then examples. Okay, so we are given an integer array nums, okay, which consists of unique elements, unique integers. Okay, originally nums contain every integer within a certain range. Okay, suppose there was a range from a to b, so it meant that all the numbers starting from a till B were the part of this nums array. Were part of this nums array. Okay, let's move further into the question. However, some of the integers might have gone missing. Okay, so it means that this was nums, which consisted all the numbers from A to B, including A to A and B as well. So what happened was that some of the numbers, suppose this one, and this one went missing. Okay, they went missing. But the smallest and the largest integers of the original array are still present. So the smallest, what is the smallest number here? Just a second, circle. Huh. The smallest is A and the biggest is 4. They are nothing but lower limit and upper limit. Okay, so they are still present. We need to return the sorted list of all missing integers. In this case, these numbers were missing, so we need to return a list which consists of these numbers, and we need to return it in the sorted manner. Let's understand with an example. Suppose the nums array was 1, 4, 2, 5, and we're given that lower limit and upper limit are still present. So they are nothing but the lowest and the biggest numbers. Okay, so in this case, what are the smallest and the biggest number? In this case, 1 and 5 are the smallest and the biggest numbers, and they are the what you can say, the range, upper and the lower range. In this case, 1 and 5, so our range is from 1 till 5. So our array initially our array was 1, 2, 3, 4, 5, and now it is 1, 4, 2, and 5. So you can say that this number went missing, 3 went missing, because all the other numbers which are 1, 2, 4, 5 are present. 1, 2, 4, 5 is present, so 3 is missing, so 3 is the answer. Okay, in this case, 7, 8, 6, 9, we know that the lower limit and the upper limit are given, so which is nothing but the lowest and biggest number, which is 6 and 9. So our range is from 6 till 9. So initially the nums was 6, 7, 8, 9, and we found that all the numbers which were the part of original array are still present. So the answer is empty array. Okay, Let's take one more example. Suppose nums was 7, 5, 8, and 11. Okay. So what could be the upper limit, lower limit, and the upper limit? Smallest and the biggest numbers. In this case, it is 5 and 11. So our range is from 5 till 11. So all the elements which are part of the original array are 5, 6, 7, 8, 9, 10, 11. And what elements are present? 5 is present, 7 is present, 8 is present, and 11 is present. So our answer array would contain, so our answer array would contain 6, 9, and 10, because all the rest elements which were part of the original array are still present. So what should be our approach? Our approach is that find lowest and biggest number, find smallest and biggest number, and iterate this range and check if this number is present or not. If no, we will add it in answer. Okay, but the main thing is how we will check if that particular number is present or not. So for that, we can use frequency map or frequency array, because we are given that nums of I less than equals to 100. So creating a frequency map or frequency array would generally be considered a constant space because its maximum length is 100. Okay, so our approach is to find the lowest and biggest element, and then we will create a frequency map to store all the elements which are present, and then we will iterate this range and check if this number is present or not. If it is not present, we will add it in a answer array. Okay, so let's implement it. Okay, so initially we just initialize min element with integer max and max element with integer min. Okay, we will create an ordered map which will store integer and a boolean to check to store that that particular element is present. And why do we use unordered map? Because we just want uniqueness and we do not want not sorted manner, because sorting will take additional time. Okay, so now we will iterate the array, or we will use for each loop. And first of all, we'll mark that particular element as present, true. We'll update the maximum element. If that's the case, it will maximum of max le and the val or value. Min element will be minimum of min le and the val. Okay, now we will iterate over the range. Which is the range is from minimum element to maximum element. Int I equals to min element plus 1. Why plus 1? Because we know that minimum element is present till it is less than max element. Why less than? Because we also know that maximum element is also present, but we need to store that in a particular array, in this case answer array. So we'll store it in the answer array. If check if that element is present or not, if m dot find I equals to m dot end. If it is not present, the pointer or the iterator will reach the end of the map. Okay, so if that's the case, we will push back the value and then we'll return the answer error. Let's check. Okay, what's the error? Unexpected. Okay, here semicolon was missing. Okay, now what's the issue? Okay, we are not M, should be M. My bad. Sorry. Okay, let's submit it. So instead of map, you can use an array as well. Let's do it using an array vector int. Let's name it frequency and its size will be 101. Why? Because we know that the maximum value of particular element will be 100. Now what we will do is if that particular element is encountered, we will mark it as 1. Why 1? To make sure that that particular element is present. Now instead of this finding, we will just make sure that if frequency of I double equals to 0, which means that that element is not present. And this searching is much faster because we are just doing directly index searching at this particular index. Okay, while in case of unordered map, we need to find in the what you can say unsorted map. Okay, this can be further optimized. Let's do that. What we'll do is we'll create that particular frequency and its size will be maximum element minus minimum element plus 1. If suppose the range was from let's see first from 1 to 5, so it would be 5 minus 1 plus 1, which means that there are 5 elements. You can say that 1 to 5 also there were 5 elements, 1 2 3 4 and 5, and then for one more time we needed to iterate the nums, and now this time what we had to do is frequency of val minus mean le equals to 1. If 1 to 5 was the range and we encountered 4, so we need to put it at what you can say fourth in 0 1 2 3 4 and 5 1 2 3 4 5, so we need to put it at third index, so it should be 4 minus 1. 4 minus 1 would work because this 4 minus the lower limit which is 1, so it would be at third index. Like if it was 5, it would be 5 minus 1. If it was 1, it would be 1 minus 1. Okay, now while we are doing this iterating over the range, now it would be I plus I minus min L and answer dot pushback. Okay, if I was 4, in this case I was 4 minus 1 which is 3. If frequency of 3 is 0, which means that that element is not present, we will push it. So yeah, I hope you guys understood the question. We solved it using three approaches. One is using unordered map, one was using map which was of size 100. The second was of declaring the array just of size which is equal to the range, and you can see that our runtime bits 100%. Okay, so if you guys have any doubt, do let me know. The what you can say, the time complexity of this final approach is O of n and O of n. Thank you.